Welcome to the DIY Honda Garage channel. The DTC P24BE indicates an issue with the canister changeover valve control circuit, specifically highlighting a low voltage condition. The canister changeover valve, which is integrated with the evap leak check module, is critical in managing fuel vapor emissions. The valve directs fuel vapors to the engine intake and regulates the flow of these vapors to prevent excessive emissions. The Powertrain Control Module, PCM, monitors the valve's operations and responds by altering functions to ensure optimal vehicle performance. A low voltage reading suggests that the PCM detected a problem when no signal should be present, which can disrupt normal operations, potentially leading to fuel system issues or increased emissions. This guide will provide a comprehensive troubleshooting process to identify and resolve the DTC P24BE error. The canister changeover valve plays a crucial role in controlling the flow of fuel vapors. It regulates the direction and release of vapor from the fuel tank to the engine. Its integration with the evap, evaporative emission control system, leak check module, is essential for monitoring vapor emissions. In the Honda CR-V's fuel vapor system, this canister is typically located near the fuel tank or along fuel vapor lines. The PCM, which oversees the vehicle's engine management, monitors the valve signals to ensure they are within specified parameters. When it detects a low voltage in the control circuit, it stores DTC P24BE, indicating an abnormality needing investigation. Identifying the exact location and function of the valve is essential for proper diagnostics and repairs. Several factors can contribute to the appearance of DTC P24BE. First, a faulty canister changeover valve may not respond appropriately to PCM commands, resulting in low voltage signals. Second, wiring issues, such as shorts or open circuits in the valve's electrical connections, can disrupt communication, leading to abnormal readings. Finally, a defective PCM may misinterpret sensor data or fail to deliver correct voltage levels to the canister valve. To accurately diagnose the root cause of the issue, a comprehensive inspection of these components and their related circuits is necessary. Evaluating each potential cause, beginning with the most straightforward checks, allows for effective identification and resolution of the DTC P24BE issue. The DTC P24BE may manifest in several symptoms that affect vehicle operation. One noticeable symptom is increased fuel emissions, as insufficient control over vapor management can cause excessive release of harmful vapors. This condition can lead to a decrease in overall engine performance, as the correct mixture of fuel and vapor is essential for optimal combustion. Moreover, the check engine light will likely illuminate on the dashboard, alerting the driver to an underlying issue with the vehicle's emission system. Addressing these symptoms is critical to prevent potential long-term engine damage and ensure compliance with emissions regulations. Understanding these manifestations will aid in recognizing when to initiate troubleshooting procedures. Step 1 of troubleshooting DTC P24BE begins with turning the vehicle to the on mode without starting the engine. This action prepares the vehicle for diagnostic testing. Next, utilizing the Honda Diagnostics System, HDS, run the evaporative emission control system leak check module test. This specialized test evaluates the functionality of the module and can reveal if it is operating correctly. If the HDS indicates the result is not okay, this signals that the failure is present and should be replicated. Following this confirmation, it is essential to delve deeper into the diagnostic procedures to pinpoint the exact cause of the low voltage condition affecting the canister changeover valve control circuit. In the second troubleshooting step, focus on inspecting the IGPS, ignition power supply circuit, which provides power to the canister changeover valve. Disconnect the evap leak check module connector and use a multimeter to measure the voltage at the circuit when the ignition is on. Under normal conditions, a reading of 12 volts should be present. If the voltage is abnormally low or absent, it indicates a potential issue within the circuit that supplies power to the valve. This could be caused by damaged wiring or poor connections, so it is critical to inspect the integrity of the circuit thoroughly. Any irregularities found during this inspection will guide further diagnosing and ultimately lead to a repair solution. Step 3 involves a more detailed inspection of the canister changeover valve, CCV open wire. With the evap leak check module connector, 8P, and the PCM connector A, 50P disconnected, check for continuity across the CCV circuit. The resistance should read less than 1 ohm. If it reads higher, there might be an open wire or a poor connection somewhere in the circuit. Alternatively, if the wiring appears intact, verify that the CCV is not shorted to ground. If the resistance is above 1 megaohm when the valve is off, it could indicate a short issue that needs addressing. These inspections are crucial in confirming whether the wiring or the valve itself is at fault in the P24BE circuit. For the 4th troubleshooting step, the focus shifts to checking the evap leak check module, as it is challenging to test directly. Since error codes can often arise from components other than those directly indicated by the DTC, installing a known good evap leak check module can provide insight into whether the issue lies within the valve itself or elsewhere in the system. After replacing the module, attempt to replicate the original fault condition that triggered DTC P24BE. If the error persists upon testing with the new module, it is likely that there are issues with other related components tied to the overall system. Conversely, if the DTC clears, this directly points to the evap leak check module as the source of the problem. In the final troubleshooting step, focus on inspecting the powertrain control module, PCM, particularly if previous inspection steps yielded normal results. The PCM is responsible for interpreting signals from various sensors and actuators, including those from the canister changeover valve. If all other components had been ruled out as causes of the DTC P24BE, it suggests that the PCM itself may have malfunctioned. Conduct diagnostic tests to ensure that the PCM is functioning correctly and that it is able to interpret signals accurately. If all indicators confirm that the PCM is at fault, it should be replaced to resolve the DTC and restore proper vehicle operation. After completing all necessary repairs and replacements, the final step in the troubleshooting process for DTC P24BE is to verify that the issue has been resolved. Begin by clearing the DTC from the vehicle's onboard diagnostic system to reset the parameters. Following this, rerun the diagnostic tests, including the HDS tests prior used, to ensure that the previously indicated problems have been resolved and that no further trouble codes appear. If the vehicle passes all tests without errors, it confirms a successful repair. This step is essential for assuring both the mechanic and the vehicle owner of the reliability of the repairs conducted, ensuring smooth and compliant vehicle operation moving forward. Preventive maintenance is crucial in avoiding future occurrences of DTC P24BE and ensuring the continued health of the vehicle's emission system. It is advisable to conduct regular inspections of the entire evap system, checking all connections for looseness and wear, which can lead to malfunction. Preventative diagnostics should be performed periodically to catch issues before they evolve into more significant problems. Keeping an eye on voltage levels and the functionality of all components related to the canister changeover valve can save time and resources. Maintenance not only promotes vehicle performance, but also guarantees environmental compliance, a critical aspect of owning a modern Honda CR-V. Investing in regular preventative measures will lead to a more reliable vehicle over its lifespan. In conclusion, understanding DTC P24BE is paramount for effective diagnosis and remediation of issues within Honda CR-V's emission control system. Recognizing the symptoms tied to the canister changeover valve control circuit low voltage allows for quicker intervention. Each of the outlined troubleshooting steps aims at identifying and correcting issues, ensuring the vehicle meets operational standards. Finally, adopting a preventive maintenance approach will safeguard against future occurrences, promoting long-term reliability and efficiency. By staying proactive and informed about the vehicle systems, owners can maximize their Honda CR-V's performance while contributing to a cleaner environment. Diligence in these areas will enhance both vehicle longevity and owner satisfaction. Please like and subscribe to the channel. See you next time.